These things are amazing. They will allow you to make a lot of calculations about mechanics very easily. You are likely familiar with a lot of the vector concepts due to the past courses you've taken, such as Physics 121. So a lot of this stuff is going to be review. And this video will be relatively easy, so if you think you have a very good background in vectors, you should probably skip to the next one. The definition of a vector is a quantity with a magnitude and a direction. One example would be a velocity vector. Another example would be a force vector. For these elements, it matters where the vector is pointed, because I could say, yes, the magnitude of the velocity is, let's say, 3 meters per second, but it matters whether I'm going in that direction or this direction, because we want to see where things are going. So that's why this component is important. Now, there are multiple ways to show vectors. Let's say we have a vector that looks like this, and this is our x-axis, and this is our y-axis. And let's say that this angle is 35 degrees, and the magnitude of this is 5 newtons. So this is one way to show that vector. We're basically showing it graphically. It's just an arrow that has an angle and a magnitude. Now, another way to show this vector is using this format. Some magnitude times I, j, and some magnitude times k. This is the Cartesian method. The letter I is referring to the x direction, the letter j is referring to the y direction, and the letter k is referring to the z direction. So this vector is on the xy plane. So when we're talking about planes, we're talking about this. So we have x direction, we have a y direction, and then we have a z direction. So this plane that I drew, it's not super clear, so let me just do another one. Multiple examples. It's looking a little crooked. There you go. So let's label this. This is the xy plane. Both the y-axis and the x-axis live on this plane. This vector lives in the xy plane. This vector, I will redraw it here, a little bigger because it's easier, has an x component and a y component. So we know the x direction. The x component of this vector, let's call it vector f. This is fx and fy, where we are getting this x, and we're looking at the x-axis, and we are projecting this here. So this might sound fancy, but all we're doing is, if this is that, and there's this direction, just draw a perpendicular line from here. And here are some quick equations on, quick but very useful equations. You probably already know them, but fx is, let's say this is theta. Oh, we already defined that, so it's going to be 35 degrees. Fx in that case is f times cosine 35. So basically f times cosine theta, where theta is this angle right here. And then fy is f times sine theta. So now let's talk about this. What this guy is saying is, we have this vector, and one way to show it, like I said, is the arrow and the angle, right? So right now we're showing it graphically. Another way is show it fx times I times fy times j. This is what gives it the direction. So the I and j give it the direction, and fx and fy give it the magnitude. So let's say we had another vector. This will be a quick example, not going to do much explanation. We have z, y, and x. So this vector, so now I will draw a straight vertical line down to the xy plane that we mentioned, so this area right here. I drew that vertical line, and once I hit that, let's say I draw a line from that to the y-axis, and a line from that to the x-axis. And that gives us, if I add, so let's say I want to get from this point, our starting point, to our end point, which is B. I go from A to this location, so one vector here. I go from this location to this location, another vector in this direction. And I go up another vector. So if I add this vector, so small a, small b, and small c, if I add these three together, then I get this big vector, which is our resultant vector, we could say. So, oh, that's not our, we use this course. So these are all vectors here. So yeah, you get the idea. Before we move on, I'm going to touch on one more thing. We know the head to tail addition property of vectors. So we have one vector here. We have another vector that goes from this location to here. And we have another vector from this location to here. If I were to say, show this vector using another vector, then you would basically draw a line from the starting point to the end point right here. And similarly, if I were to give you the vectors like this, then what you would do is you would just grab this blue guy, put it at the top, so it would look like, let's say, this, and then grab this yellow, the green guy, and then like that. And then to get the resultant, you would simply draw a line from here to here, which would look like this. So we get the same resultant vector in both cases. So these are just some properties of vectors that we should be really familiar with at this point. Another thing that we need for this course is the law of sines and the law of cosines. Let's say we have a triangle. Let's make a better one. That's better. And the angles are B, A, C, and the corresponding length. So for the, let's say like this is angle C, so this length is length C, but capital C, and this length is B, and this length is A. And the law of sines says that A over sine A is equal to length B over sine angle B, and this is also equal to length C over sine of angle C. Similarly, we have another law called law of cosines, which states that the angle C squared, sorry, the length C squared, this is capital C, length C squared is A squared plus length B squared minus 2 length A times length B cosine angle C. This is small c right here. So this is the law of cosines. So that's pretty straightforward. And now we will look at some units, some metric prefixes. Again, these are also important because at this point you should know them, but if you don't, you should. Let's say I say 1 kilonewton is equal to 1,000 newtons. And the reason is kilo is 10 to the 3. This stands for 10 to the 3. So it is 1 kilo, so 10 to the 3 newtons is equal to 1,000 newtons. So that's how it works. I could say 1 mega newton. Since mega is 10 to the 6, then we'd be looking at 1 million newtons. So you get the idea. I'm just gonna write out the prefixes now. So the things you're probably gonna see in this course. The prefixes are giga, mega, kilo, micro, nano. Oh, forgot one in there, and milli. So examples are gigameter. No, let's say gigaton, mega newton, kilogram, milligram. We could say micrometer and nanometer, let's say. So this would be 10 to the 9, 10 to the 6, 10 to the 3, 10 to the negative 3, 10 to the negative 6, and last 10 to the negative 9. So correspondingly, 1 gigaton is 10 to the 9 ton. 1 meganewton is 10 to the 6 newtons. 1 kilogram is 10 to the 3 grams, so on and so forth. So that covers everything for this video, and have a nice day.